Right, in this lesson we're going to be going over what secondary storage is and why we need it, along with looking at the three main types of secondary storage. So secondary storage is there because your primary storage, which is RAM, is volatile. And that means that as soon as you turn your computer off or you lose power, your memory will be lost or your data is lost. So if it wasn't for secondary storage, then you wouldn't be able to save any of your photos, pictures, programs, or any data when the computer was turned off. So it's very important that we've got secondary storage. When you download an app from the App Store or iStore or whatever, it gets stored on your secondary storage on your phone. When you install a game from a disc on your Xbox or PlayStation, whatever, it gets stored on secondary storage. Okay? So without it, we wouldn't be able to use computers properly. So there are three main types of secondary storage at the moment. There's optical, magnetic, and solid state. Now, in reality, it's a changing era. So solid state is becoming the main source of long-term storage, non-portable, sort of like, portable, but sort of not one you would send out. Optical is still being used to sort of buy from shops, but is quite old technology itself. And magnetic is sort of dying because it's not as good as solid state, but it is still around because it's cheaper. So I'm going to go through how they work, so you've got an understanding. You don't need to know at a very high level, but you do need to have a little bit of understanding about how they work for this course. So optical. Okay, optical means light. I hope you know that. So it's a laser light, creates marks in a pattern on the disc, and a laser light detects where the marks are and translates this into a readable format. So the thing with optical formats, which is like CD, Blu-ray, DVD, is they have a process what's called being burnt. And basically, they're not actually burnt, but I think it's because it's got the word laser in it and people think of lasers as burning it. Basically, the laser makes the disc. Okay, the disc comes off and it gets printed. And once it's printed, it's not changeable. So that's the thing with optical. It's not meant to be a changeable storage format to store like your films and your apps on. There is a version of optical that does this, but it's not very good. It's meant to store files really to be sent to someone. So once you've made a film, you put it onto DVD and then you sell the film. There you go, that's it. And the benefits to optical are it's easy to post, it's light, they're very cheap to print once they've been made a master. They get a master copy and then it's like a penny a disc. They can churn them out. So they're quite easy to take somewhere and take home. So you buy a game on a disc, you bring it home, put it in. The problems with optical discs are you can't write to them very easily. Now once they've been made, they're it. They're quite easy to scratch. And generally they're not very big. They haven't got a lot of size on them. They're not massive, although newer ones like Blu-ray have got bigger sizes, but still. So we're going to have a quick look at a video which shows how they work. It's a bit loud. Just going to go onto the web.
To play back the information on a CD or a CD-ROM disc, a very narrow laser beam is used to strike the microscopic pits or depressions and the flat areas called lands on the disc. When the laser beam hits a pit, the beam is diffused and not reflected back to the photodiode. When the laser beam hits a land, the beam is reflected back to the photodiode. The off and on signals passed on by the photodiode are then processed in ways that cause the display of sound, images, or text.
Right, so just so you understand, essentially it shines a laser onto the disc, and then when it's been printed, that laser will either bounce off of the disc and then get read, or it will be absorbed by the disc and not be read. So the ones that bounce off are 1, the ones that are absorbed are 0, and you get 0, 1. So essentially when the light bounces off it ends up sort of strobing very fast, and they're the 1s and 0s, and that's how optical works. Okay. Another reason optical is a bit old technology, it's got moving parts in it. And anytime there's moving parts, it's normally old. So that's optical. Okay. Magnetic, basically, inside the disc here, this is a magnetic hard disk drive. There are loads of little tiny parts of magnets. Now they're not actually magnets as you know them, but they're metal that can be turned into a magnet. So you must have done that thing where you make an iron into an electromagnet and you can pick up nails and stuff. Well, this thing here is an electromagnet, and as it goes over the disc, it can either read the magnetism or write it. And this video shows a much better idea of what it does. So as you can see here, as it reads over, what it can do, it can either make the parts of the magnetic disc north or south. So you know you've got like a north part of the magnet or a south part. Well, as it goes over, it can either make it north up or south up. So that's north pointing down there. So it either makes the magnet one way up or the other way up. And essentially this way represents a 1 and this way represents a 0. And as it goes over, it can either be in read mode where it reads 11110, or in write mode where, as it shows you here, it's actually setting the data to the number, to the way it is. So it can actually change, as it goes over, it can either change the polarity of these magnets or it can read them back. And that's how magnet hard drive works. Now, magnetic hard drives are very cheap. They're very large in capacity, but they're old technology. And the reason they're old is because they have literal moving parts in it. So literally that disc spins round and this head's got to move around like really fast. So because there's an element of time taken to spin, it's just a bit old technology. And actual moving parts is old technology. You know, this can break, motors can break, you know, things can go wrong. And so, yeah, they're really cheap and they're quite big in terms of capacity. They're also not very portable because there's a spinning disc in it. So, for example, I used a hard disk drive, which is magnetized in your phone, which isn't used, by the way. When you move your phone around, this disc would smash against his head and the data would be corrupted and it'd be very bad for it. So magnetic's not good for moving around very sharply. I'm not saying they couldn't use it on a laptop, but I mean like something that's going to move very fast, definitely not. And it's just not as fast as some of the more modern technology. So the more modern ones, which are used in all the new games consoles, PlayStation 5, Xbox Series X, is actually solid state. So the main thing with solid state is a solid state drive, as is shown here. But you also get memory sticks of solid state. And basically, there's no moving parts in here. All the data is just stored in microchips as zeros or ones. Just like inside the computer CPU, they're stored as zeros or ones in there in chips. It's exactly the same. The benefit of this is that they're really fast because there's no moving parts. They're portable in terms that you can move them around, throw them, because unless a microchip actually cracks, you know, it doesn't matter if it gets dropped, you know, as long as it doesn't actually snap in half, which is very unlikely unless you actually try and break them, you know, they're quite robust. The only negative side to me is they're a little bit expensive at the moment, you know, size to money. So this 512 gigabyte drive might be £100, whereas you could get a 6 terabyte, so 12 times the size of that for the same money as a magnetic hard drive. But these are getting phased out. So that's basically it. Here's a sort of rundown of it. Okay, so you've got optical discs are cheap, easy to send in the post, not reliable and they're small. Solid state drives are very fast, very reliable. They're physically small as well, solid state drives, like physically small, which is good for phones and other things. But they are expensive. They're not as big in capacity, so like how many megs and gigabytes you can store, as hard drives, which are magnetic. And magnetic, obviously, it's just a mix of all of them. It's reasonable speed, good value, good capacity, but they can break if they're dropped. Because if you drop a magnetic hard drive, that disc and that head are going to bang, and that will cause errors. So that's why it's not good for like a phone or some other things. So that's basically it. I won't bother with that. So what have you got to do? Right, so you're going to find in your folder, a Teams folder, a PowerPoint that is set up like this, which has got the types of storage in it. So what I want you to do is put the 3 types of storage in there. Okay, you can look through this video. You're going to quickly define the type of storage. So optical storage stores data with reflecting light on a disk. You know, magnetic stores it in terms of a magnetic polarity, north and south. And solid state stores it as electronic switches in microchips. Talk about some of the devices. You know, optical's easy, I mentioned those. Magnetic, you have hard disk drives, you've got data tapes, you know, there's old cassettes, you know, they're magnetic. Old, you know, videos on tape, they're magnetic. With solid state, you've got, you know, SD cards, you know, USB sticks, solid state drives, but you can do a bit of research, maybe get a couple of pictures on there as well. I haven't put, maybe jig the space around, yeah, and complete that nice and neat. We do not want, and I say this a million times, copy and pasted rubbish. Just 1 or 2 lines of real written words, in your own words, defined. Just 1 or 2 words. And the characteristics you can obviously get from this page here, so I'll leave that up for a little bit of extended time, but you can pause obviously. Get some of those on there. In case you hadn't realised, the pluses are positive and the negatives are negatives. But you should have realised that. Anyway, so good luck, and then any questions, just email him.